Student, we are already know that the transformer are two type. One is the core type and another is the cell type. Now, the core of the transformer is made by the CRGO, that is cold rolled grain oriented silicon steel. So silicon steel here used to minimize the hysteresis losses. Why we use CRGO? Because CRGO, that is cold rolled grain oriented silicon steel, have magnetic induction is maximum and the loop of BH curve is large. Again, magnetostriction is very low, good mechanical property, and coal loss during no load operation is very low. Due to this advantage, we use CRGO material in for the core. Now, the core of the transformer are laminated in order to reduce the eddy current losses. The eddy current is proportional to the square of the thickness of lamination. We are already know about that. So that the thickness of lamination should be extremely small in order to reduce the eddy current losses. The laminations are made 0.33 to 0.5 millimeter thick. The thickness should not be reduced below 0.3 millimeter because in that case the lamination become mechanically very weak and tend to buckle. So very simple, core is made by the CRGO. Why CRGO is used? We are already discussed about that. And core is laminated to reduce the eddy current loss. Eddy current loss is the square of the lamination thickness. The lamination thickness should be 0.33 to 0.5 millimeter. Thickness should not be below 0.3 millimeter due to below 0.3 millimeter it is mechanically weak. Actually, this core are segment as E segment, L segment, I segment, etc. So, during the construction of transformer, the core are staggering of butt joint, avoid construction air gap. Therefore, the reluctance of the magnetic circuit is not increased. At the same time, a continuous air gap would reduce the mechanical strength of core and therefore staggering of butt joint is very essential. So this is the core butt joint, that is the butt joint, and layer here, that is second layer, fourth layer, sixth layer, so on. Similarly, it can be 1, 3rd, 5th, and here the butt layer, that is the butt layer. Okay. So the staggering of butt joint, the staggering of the butt joint, avoid continuous air gap. Therefore, reluctance of magnetic circuit is not increased. Okay. There are several types of core winding in a transformer, that is cylindrical winding, helical winding, double helical winding, multi-layer helical winding, crossover winding, disc and continuous disc winding, and aluminum foil winding. So these are the type of the windings in the core type transformer. Now, in low power transformer, always air cooled, where the large power transformer are immersed in oil for better cooling. So here oil serves as a coolant and also insulating medium. Basically, there are two types of cooling, that is air natural, air blast, and oil natural. Now, how the transformer acts? In case of core type transformer, half of the low voltage or high voltage winding one limb and other half on the second limb. And in case of cell type transformer, low voltage and high voltage winding are sandwiched. Here, for simplicity, we draw a simple transformer and connect a alternative voltage source, that is V1. As source is connected here, so this winding is the primary winding. Now, this alternating voltage, due to this alternating voltage, a alternating current, suppose IE, flow through the primary winding. That is, here number of turns, suppose N1, and either side, that is the secondary winding, number of turn N2, and it is denoted as it is secondary, we write as a S. The alternating current set up a alternating MMF, that is IE N1, that is the primary MMF. This primary MMF produce a alternative flux phi, which is confined in this core, that is highly permeable. This alternating flux induce a voltage in primary winding E1 and also induce a voltage E2 in the secondary winding. If we connect a load across the secondary That time a secondary current, suppose I2, flow through this path. As the applied voltage here sinusoidal, so that the exciting current IE also sinusoidal. Due to the flow of exciting current in N1, that is N1 into IE, that is primary side MMF, is created, so that alternating flux flow through this path. That is also alternative in nature. So flux phi can be written as phi max sine of omega t. Now the induced EMF E1 in primary side, due to the presence of number of turn N1, that should be written as E1 is minus N1 d phi by dt. So minus N1, so simply minus N1 dt of phi m sin omega t, that is minus N1 phi m omega cos of omega t. So due to this minus, we rewrite that N1 phi max omega sin omega t minus pi by 2. Now this value of E1 should be maximum when sin omega t minus pi by 2 is equal to 1. So sin omega t minus pi by 2 equal to 1. That time E1 max, written as the equation as E1 max, N1 omega phi max. So the RMS value is nothing but, in case of sine wave, that is maximum divided by root 2, that is N1 omega here 2 pi f into phi max divided by root 2. So E1, it is root over pi f N1 phi max. Now similarly for the secondary winding, it is E2 minus N2 d phi by dt, that is N2 phi m omega sin omega t minus pi by 2. So that E2, the RMS value, it is root 2 pi f into phi max. So from this two equation, we simply write that is E1 by N1 equals to E2 by N2. That is EMF per turns in primary always equal to the EMF per turns in secondary. So remember that EMF per turns in primary is always equal to the EMF per turns in secondary.